Hi there, and welcome to an Advantage Security Controls tutorial video. In this video, we'll be working through introductory steps to using the REST API module via PowerShell. My name is Steve Young, and I'm a Senior Technical Support Engineer from the Security team in the EMEA region. As we move through this video tutorial, I'll be frequently referencing the dedicated REST API help section, which you can find online at the following address. The REST API help pages are an extensive catalogue of all the API functions and requirements to get you started. There's a dedicated section for requirements, helpful tips, and more. Let's get started by taking a look at what this video tutorial covers. In section 1, we'll look at the account requirements for running REST API requests and how to prepare the remote endpoint for sending requests. In section 2, we'll briefly take a look at the two different PowerShell methods you can use to send requests and what the benefits are of using each of these methods. Moving on to section 3, we'll be managing sessions for the REST API service, which will allow us to post and get requests later on. For section 4, we'll start using the REST API service by performing a GET request, and then look at how to read the resultant object. In section 5, we'll then look at performing a POST request to submit a new request to the API service and what format the request body needs to be created in. And finally, in section 6, we'll look at assembling a simple script combining each of the methods and how to add login to our script to allow for troubleshooting when things aren't quite going how we intend. Let's kick this off by looking at the requirements for the service accounts we'll be using to eventually send and receive our REST API requests. On our Security Controls console server, we need the service account as a member of the local administrators group so that it has access to the Security Controls console. If you use role assignments in your environment, you'll also need to make sure that it's added to the role assignments page so that the console can be opened as the service account. In my scenario, I'm using the account svc_REST API for all of my REST API requests going forward, so I'm going to add this directly to the group. Once added, we'll also need to make sure that the log on as a batch job user rights assignment privilege is configured to allow administrators. Again, we can add our account directly to the privilege to ensure that the account has the necessary privileges. Next, we need to configure the account on the server itself inside Security Controls. We'll set up a service credential and then make the configurations to our machines and machine groups so that the REST API account has configurations to read when we execute our REST API requests. So first of all, you can use the PowerShell whoami command to verify that you're logged on as the service account. Once logged in, open the Security Controls console application and we'll get started by setting up a credential object for the service account via the Manage Credentials window. After the credential object is created, click the Share button at the top and share the credential with background services. You may also want to take ownership of other credentials at this point and share them to the service account, or alternatively, log into the console server with the credential owners and share the credentials with the REST API service account. Once you've provided the service account with the access to the necessary credentials, you'll need to assign these to each of your machine groups as well as each of the machines via machine properties. And finally, to round off the requirements section, we'll need to prepare the endpoint machine we intend to use to run the REST API requests from. As previously mentioned, the help section is a catalogue of everything you need to use the REST API service. This also has a dedicated page for how to set up the remote endpoint. In this video, we'll be using the automatic configuration process using the setup script. To create the script file, open the Security Controls console and navigate to Tools, Options, and then select the API tab. On the API tab, we can either save the script straight to a file or copy the script to clipboard to open it in your own custom editor. In this scenario, we'll just be saving the script to a file and then we'll copy the file to the endpoint device where we can run it with elevated privileges. Now that we're set up for using the REST API, let's take a look at the two PowerShell methods we can use to send our API calls. On the left we have the invoke REST method, and on the right we have the invoke web request method. I've already performed the execution of both of these and received a response, So to view the stored response on the left, I'll use the $IRM call to view the object. The object displays as a standard JSON object with two properties, count and value. To read the actual response of the request, we'll recall $IRM and append the property value to it so we can look at the contents in a readable format. On the right, we can call $IWR to see the response from the invoke web request method. This displays the content differently as it is a raw web request response. If we then append the content property to $IWR, we then get the same information as per the invoke REST method request, but it is not presented in a readable format in its current state. To get the web request response in a readable format, we need to use the convert from JSON method and provide it with a content to convert it from. I've stored this in a new variable called $content to reference it afterwards. Now when we query the value property, we have the same interactable response as per the invoke REST method. These two methods each have their own benefits. The invoke REST method is easier to use as it already converts the content into a readable object, which means this can be interacted with immediately. The invoke web request method, though, provides much greater detail. This can be more useful for troubleshooting and finding issues with your API requests as you can view the response you're receiving directly from the API service. We'll be using a combination of both of these methods throughout the video tutorial. Let's get started by setting up a session credential for calls using the invoke web request method. To begin, we'll need to be running PowerShell's integrated script editor whilst elevated as administrator. In the script area, we'll first declare a variable called cred where we can store our credential object. We'll be creating the credential object using PowerShell's getCredential method. As we're using the post method to create the session credential, we'll need to create a request body for the request. A request body contains the necessary information required to allow for object creation. We'll take a look at request bodies in more detail later on in section 5. With the credential object and the request body provided, we now want to use the invoke web request method to perform the API call. But first, we need to know where we need to submit this request. On the help pages, navigate to the credentials page and look under the post section of the table to identify the session credentials web address. In the third column, we can see that the post request requires an input of a session body. You can click the link to view the contents of the body and use this to assemble the request body. We'll copy the address from the second column in the table, as we'll need this for our URI parameter in the web request. We'll start our request by declaring a request variable so that the response from the request can be recalled and queried as an object. Then, we'll call the invoke web request method and provide it with the method of post as we're creating something. After specifying the method type, we need to declare the URI parameter for the address that we copied from the help pages. We'll need to modify the address though to use the console server's fully qualified domain name and the port of 3121 to amend the address to our environment specific address. After the URI parameter is declared, we need to declare the credential object we want to use for the request, and subsequently what we want the session credential to be declared as. Next, we'll input the request body using the body parameter, and then add on what type of content the request body is presented in, which is the application/JSON format. And now we're ready to send the REST API request. As we've used the PowerShell getCredential method, a login box appears for us to enter our credentials. In this case, we've hit an error. The PowerShell response is stating that Internet Explorer hasn't gone through its initial configurations. We can either use the Use Basic Parsing switch to bypass this issue, or we can launch Internet Explorer and allow the initial setup to complete. Let's head back and rerun our request. No error message is presented this time, so we can call the request variable to see what the status of our request is. We can see in the content that the response is code 201, which means the post request was successful and the requested object was created. Now that we can create a session, we need to also know how to delete a session. If we attempt to rerun the same session credential post request, we're presented with a conflict error. This is because the session credential already exists and needs to be removed before a new session can be established. Let's comment out the existing code using the hashtag and arrow brackets around the contents, and then create a new request variable. This time I'm going to use the invoke rest method as I know the delete request in this circumstance doesn't provide any content in response. The method required for this web request will be the delete method, as we need to remove something. For the URI, let's go back to the help pages again, and this time look at the delete pages available and extract the session credential address. Remember, we'll need to modify the address to include our console server's FQDN and port number for the API service. I've run on ahead a bit here and I've specified the credential for the operation before correcting the address. You can also add the use basic parsing switch at the end, although this is the default setting. Once the request is complete, we can execute this. As mentioned before, this provides no response. If we attempt to open the new request variable, its contents are null and nothing is displayed. We can confirm that this action was performed successfully by rerunning the create session request, which will now successfully complete as the conflicting object no longer exists. The session credential is used to establish a connection to the API service and perform the requests. If you find that your API requests aren't working properly, you may need to delete your session credential and recreate it to re-establish a connection to the API service. Now, let's move on to performing a GET request and getting the requested object. In my example scenario here, I have recently scanned a Windows 11 machine. I want to perform a GET request to obtain information about this scan. The scan itself has no identifying markers, other than the default scan name which can easily be duplicated. So I'm going to look to obtain the machine name of the device first. I'll start by assigning a cred variable to the getCredential method again, so we can work with inputting the username and password manually when executing. Once again, we'll go back to the help pages so we know what kind of API request we need to perform. By selecting the relevant page on the help pages and then looking at the table of addresses under the get category, we can identify what address we'll need for this request. You can also see that this address contains an input which can be specified as URL parameters. These are conditions that can be attached to the initial request to filter requested data based on those conditions. Further down the page, we can see what the return object is. In this case, it's a managed machine. We'll take note of the DNS name parameter, as this is what we'll be using later on. Let's copy the address and move back to our script in PowerShell ISE. To start, we need to declare a variable to store our request object in, and then we'll use the invoke web request method with the method type of get and input our address, making sure we amend it to match our environment. Next, let's assign our credential object to the request and use the use basic parsing switch to format the request. Now that we have our request created and it's stored in the machine's variable, if you can remember back to section 2 where we discussed our PowerShell methods, the invoke web request method presents us with the raw web request data, so we'll need to convert it into a readable format. Let's declare it as a new variable called machine list and use the convert from JSON method and provide the input of the web request content and output the value. Additionally, I'm going to filter this list to filter out any devices that are presented with an assigned machine group that contains the word Linux, because we know these records won't be relevant when we're searching for a Windows 11 device. Let's give this a run and see what kind of information we can get back from the API request. With the execution finished, we can use the machine list variable to read the object that we filtered from the requested content. We can see in the list that the Linux device is not present, and the record we're looking for is the last entry of the list. We can use the variable with the property of count to find out how many entries are in the array, and then use the array index of the count subtracting 1 to obtain the last entry in the list. As we're wanting to do this ahead of performing another API request, we'll need to write a couple of lines to extract this machine for us, no matter where it is in the array list. So once again, we'll filter the list by using the whereObject method and filter it based on machine name that we obtained from the console scan result, and then store this in a new variable. We'll also need to use the identifier that's valid between both managed machines and machine scan results, so we'll store the DNS name property for the machine in a separate variable for later reference. Now that we've successfully obtained a request object, let's look at reading the object and using the returned object's information to perform other GET requests. First, we'll need to look at the PatchScan's help page to help us identify what kind of request we need to build and how we get from our requested machine information to obtaining the specific scan result that was recently ran. Once again, the address we need can be pre-filtered using the URL parameters. In this scenario, we do know the start date and time of the scan, but we're not going to filter these results so we can obtain up to 1000 scan results from our request. We can also see that the return object we're looking to obtain is the PatchScan machine object, which cannot be obtained directly from the scans request we'll need to run first, so we're going to need to build multiple requests that chain on from one another using the unique identifiers to look at specific results. Let's get started by copying the address to obtain the first 1000 scan results from our database. Next, we'll store the request information in a new variable, and we'll once again use the invoke web request method of method type get to perform the request for us. We can instantly pass all of the data by using brackets to feed in what the convert from JSON method requires in order to obtain the list of scans from our database. Now that we have our scan information, we're going to use a for each loop to move through each scan, query what machines are included in the scan, and then if the scan result matches our Windows 11 machine, we'll need a way to reference that specific scan at a later time. So to start with, we need to provide a container for the scans that match this criteria. I'm going to declare it as scan list, and I'm going to create the object type as an array list. We can now create the for each loop to go through each scan one by one. Each time the loop runs, the scan variable is replaced by the current scan in the loop, so we'll be reusing the same block of code to do our query and build out our list. The requirement for running an API request to obtain details of a specific scan is that we use the scan ID in the address, so we'll start by getting the scan ID of the current scan in the loop. Next, we'll assemble the new URI so that it matches the current scan's ID, and then use the invoke REST method PowerShell method to execute our GET request. We're using the invoke REST method PowerShell method in this instance so we can obtain the information in an already readable format so there's less actions for the loop to perform. I've also appended the machines page to the URI so we can get the machine specific information straight from the scan data, so it's one less thing for the loop to perform. Finally, now that we have our machine data from the specific scan result, we need to loop through this content and look for our managed machine's fully qualified domain name and see if it matches the patch scan results machine's fully qualified domain name, and if it does, we can then add it to our list. And last of all, if our script runs successfully, we should have a compiled list of scan results that were performed against our desired Windows 11 device. But as we're looking for our most recent scan, we're going to need to format that list. We can use the sort object method to sort the list based on a property, and in this case we'll use the started timestamp of the scan operation and then set the order to descend in so that the most recent object is displayed at the top of the list. Let's execute our script and see what results we get. We can see that the returned object now only has scans for our Windows 11 device, and the most recent scan is at the top of the array list. Once again, we can then reference an object in an array or array list directly by specifying its index value in the square brackets when querying the variable. In this case, if we select the object at index 0, we receive the most recent scan for our Windows 11 device. Now let's move on and take a look at how we post requests. A post request will often require a request body, so we'll start by looking at how to assemble a request body in PowerShell. To begin with, I'm going to use a few lines of code from our previous section, as we'll need to get a machine's fully qualified domain name to submit a patch scan operation to it. I've amended how we obtain the machine object this time by using the URL parameters to identify the machine directly. This is case sensitive though, so bear that in mind when assembling your own scripts. We'll use the help section again on the patch scans page to determine what we need to submit a post request and create a new scan operation. The request body has a lot of options, but only 3 of them are mandatory and 1 is conditional, so we'll only be submitting the minimum amount of parameters within our request body on this occasion. Inside the variable labeled body, I'm creating a new list, and within that list, I've opted to cast a new array as a PowerShell custom object. This isn't entirely necessary, but it's generally good practice to ensure your objects are labeled and cast as the right object types as you create more advanced scripts. Inside the custom PowerShell object array, we're going to include the 3 mandatory parameters and 1 of the conditional parameters. These are the name of the patch scan operation, the endpoint names that we'll include in the patch scan operation, the credential ID of the credential performing the operation, and the template ID of the patch scan template we want to use and scan our machines with. Now we can start by specifying the name of the operation by simply typing it in single quotation marks to indicate that the text we've entered is of the string type. For the endpoint names, we're going to first need to obtain the DNS name of the machine object by creating a new variable called machine name, and then obtain the DNS property from the machine request. We can then insert this inside a list declaration inside the PowerShell custom object so that the name is passed from the variable when the list is read. For our last 2 required parameters, we're going to need to run 2 GET requests. Starting with the credentials, we could filter this using the URL parameters for the credential name, but we haven't got a name for our credential object in PowerShell, so we've got nothing to match it against. Instead, we'll query the full list of credentials and then we can filter the requested list against a specific username to obtain the credential we want. Now we could leave it at that and simply add the credential ID to the PowerShell custom object, but a minor improvement for this would be to substitute out the manually entered username and instead put the username from the credential variable we obtain at the start of the script. Our last parameter is to specify the scan template ID, so we'll need to perform another GET request. This time, I'll use the URL parameters specifying the name of the scan template so we grab just that single scan template object that we can then reference and pull the ID from. Now that we've completed our request body, we'll need to convert it into a JSON readable format for the web request. We can do that by using the convertToJSON method by specifying the body variable as its input object. When we execute this script, it gathers the necessary information and compiles them into the request body. We can then view the raw body we've created and the JSON converted body in their own variables and identify the difference in presentation. As we have now constructed the request body for our post request, let's move on to submitting the post request. Once again, we'll use the invoke web request method so we can view all response data, and we'll use the post method for this request. We can obtain the request address from the help section, and we'll need to input the JSON converted body type into the request, as well as specifying the content type of the body as application/JSON. When it comes to executing this post request, I've stumbled across an error. The error states that no input was provided, and this is referring to the body parameter that we've just added. Despite this displaying correctly in the JSON format in the shell, I hadn't actually specified the body variable as the input object for the convertToJSON method. So instead, I'll use the pipe function to pass the body variable into it, and this will resolve the issue. We can now check the status of our post request by opening the post request variable and see that the status code is 202, where the response is that the request was created. We can then look on our console server and refresh the results view to view our patch scan results for the selected machine. Now let's take a look at how we can combine GET requests and POST requests together to form a simple script. And before we get started, let's take a look at the script overview to see what we'll be creating in this simple script. In the first part of our script, we'll take a look at managing our sessions, where we can delete a session credential first if one is found, and then create a fresh session to use going forward. In the machine management section, we'll create a new machine group and populate it from a text file containing a few example machines and assign the relevant credentials to it for performing the scan and deployment operations later on in the script. Under the patch management section, we'll then scan the machines from the created machine group and deploy the patches that are detected as missing from each of them. So let's get going with the session management part to start us off. I've created a script framework where each area is separated with a comment header and provided some simple variable declarations at the top, which will allow me to quickly reference the required web addresses for the API, as well as the included prompt for the getCredential method with the additional parameters already pre-populating the required account's username. To start with, as the session may not already exist for us to delete, we'll need to use a try-catch to encapsulate the delete request to prevent the script from erroring out. In this scenario, we want it to continue even if it receives an error message, so I'll add in the catch for the explicit web exception response we're looking for, which is the error 404 page not found response. For the other areas of the catches, we can use these to provide an output to the console to state we've received another kind of error when trying to delete the session. Now that we have our error handling complete, we can create the delete request to delete the session. I'm using the invoke rest method here, as I know we don't get a response value back from the delete request. Now we can verify that the session deletes successfully and the error handling responds correctly. On our first run through, the session deletes successfully as we receive no response back from the console. In the second run through though, we receive the unhandled web exception response, not our page 404 expected response. This is because the value property is actually value underscore underscore and needs to be corrected. Now that we've handled our delete request correctly, we'll need to post a new session to establish one. We'll need to use the same request body as we outlined in section 3 of this tutorial video. Once again, we can run a test and verify that the session is deleted if it exists, and the new session is then created. In the machine management section, we'll create a new machine group that's populated with the machines obtained from a text file on the local machine. We'll start by outlining the request body that we'll need for the post request to create the machine group, and then we'll work back up from there. Once again, I'm creating the body as a PowerShell custom object, and then I'm converting it to the JSON format for the request. Some of the fields can't be populated in the request body, so we'll need to do some GET requests to obtain the required information before we proceed with the POST request. First, I'll look at obtaining the credential ID of the credential object that we want assigned to the machine group. I found a credential object that I want to use in my console, and then I filtered the REST API results to select the object that matches the credential name. Next, we'll need to read the list of machines from the text file, so we'll be using a stream reader process to grab the machine name line by line in the text file. As long as each machine name is written to its own line in the file, the stream reader will be able to pull the machine names out individually and place them where we need them in the script. Once we've pulled out each machine name, we want to add them to a list of discovery filters in the required format. In this case, we'll again use a PowerShell custom object to add them to the list in the required format. Now that our list assembly code is written to populate it based on any number of machines added to the text file, we can complete our request body and submit the post request to create the machine group. After executing the script, we can check in our console and see that we have a new machine group created. However, when we edit the machine group, our credential assignment is not valid. We know that the account has the credential object shared to it, but the problem is that the credential object isn't owned by the session account. So we'll need to create a new credential object while logged in as the REST API service account to assign this instead. And now that we have our sessions managed and our machine group successfully created, we can move on to scanning the machines and deploying the missing patches. I've started this section off by completing all of the GET requests to pull the required information into a request body for the patch scan post request. I've used a combination of filtering and using URL parameters to pull just the required objects and then obtain the specific properties needed from those objects. This time I've used the invoke web request method for the REST API request. This is so I can look at what the response code is and confirm that the patch scan operation has been triggered successfully. Upon execution, we can see that the patch scan results are received in the console, meaning the patch scan operation was a success. Now that we have our results, we need to make sure that when it comes to deploying patches based on those results, that the scan has actually completed its operation first. Before we can query the state of the patch scan operation though, we need to first make sure it was posted successfully, and this is why I use the invoke web request method. After confirming the operation has the correct post request status code, we can then move on to creating a loop that will requery the isComplete property of the page. I found that the page doesn't create instantaneously, so adding a 2-second delay can help to get your loop going. Inside the body of the loop, we'll use another try catch to make sure that if we do hit a page 404 not found response, we don't exit the script and we carry on retrying the code. After a few logic checks, our loop is done, and we can now write the post request with its required body and then execute the script again. While running, the loop continuously posts to the PowerShell console that the scan operation is still running, until it completes and ceases to post anymore. Finally, we can now move on to deploying the patches that were detected as missing during our scan. This is simply another GET request for the deployment template that we'll be using, and then assembling the previous information we've already obtained into the deployment request body before we can post the request. Once posted, we don't get a response back from the invoke REST method, so we'll need to requery the dedicated page for the deployment. We can use the deployment name and then use that in the URL parameter to select the specific deployment. We can also see that our patch scan operation is found under the results page, alongside a new deployment operation which can be opened in the deployment tracker. And finally, I've included this additional section for your simple script so you can learn how to output events to a log file so it can assist you in identifying what's happening in your automated scripts. For this, I've added a new section in the script where we can establish a log file, test if it exists, and create if it doesn't. And then there's a reusable function we can call to simply log lines out when we need them at any point during our script. Looking at our session management, we already have some error handling in place, but this is only surrounding our delete request. We need additional error handling around our post request in the event it's unable to create a new session, and we'll want to know why it can't by logging that out to our log file. When we execute the script and view the log file, I get a response back that isn't the recognized 202 response. It doesn't actually provide any response. This is because I made a typo and referenced a null object. Upon correcting this, we can now see the line logging correctly with a 201 response instead of a 202 response, so we can adjust the success code as appropriate in the script. Logging your output is a very effective method of finding bugs in your code and fixing your scripts. So it's always recommended that you take advantage of this and provide simple logging in all of your scripts going forward. Thank you for joining me in this Avanti Security Controls REST API PowerShell tutorial video. I hope you've enjoyed watching and learning with me, and I hope you'll join me again next time.